Okay, so we are now on day 3. We're going to talk about two different things, so hopefully I can squeeze them all into one video. We're going to talk about perpendicular and parallel lines. So we're going to start with perpendicular lines. So the vocabulary for this one is intersecting lines. There are two or more lines that cross each other at points. Point or points are called points of intersection. So for instance, I have line PQ, RS. The point of intersection would be O right here. So PQ and RS intersect, and point O is a common point between the both of them. Perpendicular lines are two rays, line segment, or lines are perpendicular to each other if they intersect or meet at right angles. PQ, line PQ, is perpendicular to line segment RS. We know it's a line segment because it doesn't have an arrow going this way. Written as PQ, this symbol right here is the symbol for perpendicular lines. So it's an upside down T. So line PQ is perpendicular to line segment RS. Properties of perpendicular lines. 1. They intersect or meet each other at 90 degrees. 2. If two lines intersect at 90 degrees, they form 4 right angles at the point of intersection. And that's when it's two lines that are intersecting. So we have a couple of examples. I would like you to check and see if you guys can predict or identify the correct, looking at a graph, check and see if you guys can identify which ones are perpendicular and which ones are not. So there are 4. I'm going to show you A and B, which is up there right now. This is C and D. I'm going to please pause it and then see if you guys can figure it out. So A, B, and C, D. A, B again, and C, D. So looking at AB, remember, in order for us to see if they are perpendicular lines, they have to meet at a 90-degree angle, and they should form 4 right angles if they are two lines. So looking at AB and CD, they are all lines, so we can choose to look at to see if they all have 90-degree angles. If I look at A, I see this is an obtuse angle. I know it's not a right angle because I don't have that little symbol of a square or rectangle showing that it's 90 degrees. However, for B, I do have that little block letting me know that I have a 90 degree right here. So A is not a perpendicular line, B is. Looking at CD, C is a perpendicular line because I do see that block letting me know that this is a right angle. D does not even intersect, so that one point where it's supposed to intersect at 90 degrees does not even apply for D. So to double check and make sure that we got it right, A is not perpendicular because they do not intersect at 90 degrees. B is perpendicular because they intersect at 90 degrees. And C is perpendicular because of the same reason, and D do not even intersect, so they're not perpendicular. So for example 2, it says, consider the cue below. Identify any 4 pair of perpendicular line segments. So line segment, again, are 2 endpoints, and we can kind of look and see which ones would be perpendicular. Where since this is a cube, we know that every square or rectangle have 90 degrees. So there are quite a bit. So consider the cube below, identify any 4 pair. So I need 4 of them. So pairs means I'm going to have 2 letters for one pair, 2 letters for another. So for instance, EF, segment EF would be perpendicular to ED, because this would be a 90-degree angle. EH would be perpendicular to HA. AD would be perpendicular to DC. Basically anything, any line would be perpendicular to a touching line. All right. BG and HA would not be perpendicular because they do not even touch each other. So these would be all the combinations where line segments would touch and or intersect and create 90-degree angles. So if you kind of want to go back and forth and look between the two and see if you can figure that one out too, you guys can do that. I'm going to keep it up there for just one more second. So this is just a list of all the combining ways that the line segments would create perpendicular lines based off of that cube from before. Alright, so we're going to practice a little bit more. Identify pairs of perpendicular lines or segments in the figure below. So again, we're still going and we're going to still talk about lines and line segments. I also see that we have a few rays as well, but it's asking us for line and line segments. So if I look, I have line AF and I have line segment AC. I believe that would work. I have line FE and line segment DB would be one. So it's just kind of going around and looking and seeing which line segments you can see. So I would probably copy this down and then write down these answers. So line segment or ray AC and line AF, line AD and line DB, line DB and line FE, ray EG and line FE would be answers to the previous question. So we're moving on forward to parallel lines. So I know it says day 4, but we're kind of doing it with day 3 just because they kind of go together. So the vocabulary for this section is this is a connection of so many points that extends continuous in both directions. By saying a line in the presentation, we will be referring to a straight line. So every single time we talk about a line, we're talking about a straight line because there are different versions of lines. Parallel lines, these are a collection of two or more lines whose distance between them do not change. Right? So parallel lines means they don't touch each other. They are lines whose distance between them do not change along their length. In such a situation, they do not meet. Wow, I really needed to spell check and grammar check this. The diagram below shows 3 sets of lines where, in each set, the lines are parallel to one another, meaning that when they talk about the distance, they mean the distance from one line to the other. They do not meet. So all 3 of these are parallel. These 2 are parallel even though they're diagonal, but they still will not touch. When we say distance between parallel lines, we mean that the shortest distance between them is the same, meaning from here to here. All right, so from one to the other. This shortest distance is represented by line segments that are equal and perpendicular to the pair of others. So from C to D, that's line CD, and line AB. Line segment ML would be perpendicular to these 2 lines because they create a right angle. In the figure above, meaning this one, line AB and DC are parallel lines, while FE HG, ML are equal perpendicular lines. Small marks on the line imply that they are equal. So if you see this one line and we're wondering why those are there, it's just letting you know that the distance between F and E, H and G, and M and L are exactly the same. So if this one was 2 inches, this one would be 2 inches, and this one would be 2 inches. That shows the distance equal, the equal distance along the length of the line's parallel lines. Parallel lines are denoted by two parallel short lines. These two little lines, very close to each other so that you don't confuse them with like an 11. Thus, we are writing line AB is parallel, these two lines let me know that it's parallel, to line DC. To mean parallel line is line AB is parallel to line DC. Basically exactly what I said, but yeah. Sometimes parallel lines are drawn with extra arrows to show that they are parallel. So if you see this little arrow and this little arrow, it lets me know that line L1 and L2 are parallel to each other. These two have two little arrows, letting me know that these two lines, line 4 and line 5, are parallel to each other. Actually, this arrow right here lets me know that 1, 2, and 3 are actually parallel to each other. I didn't notice this one at the beginning. In the figure above, line 4 and line 5 are parallel and have two arrows showing that they are parallel to each other, and note that the other lines have one arrow. Likewise, 1, 2, and 3 are parallel to each other. So example 1, identify parallel lines among the following figures. So I would copy this down and I would try and see which ones go with each other. So I would mark them with one arrow if they all go together. I would mark them with 2 arrows if they go together, or 3 arrows. So copy that down as best you can. It doesn't have to be 100% perfect. You don't have to like put your paper on top of this and then trace it if you don't want to. You can if you would like. So parallel lines cannot meet and have an equal distance along their length. Based on this concept, we have that. So we know that line 1, 2, and 5, 1, 2, and 5 are parallel to each other. 6 and 7, and 3, 4, and 8. So 6 and 7 are parallel to each other, and 3, 4, and 8 are parallel to each other. So practice. Draw lines L and M and let them be parallel to each other. It can pretty much look however you like. It does not matter because if I draw them correctly. Wow, that's not straight, but pretend that it's straight, and pretend that's straight. I could draw them like that. I could draw them like that. It doesn't matter. As long as they're straight. Wow, I can't draw straight on my computer. So, as long as they're straight. And that's the end of this video.